Hello everyone, please write in YouTube chat if you can hear me well. Great, so we can start. Thank you all for joining our webinar and deciding to spend this evening with us. Let me introduce myself. My name is Lana and I'm HR Manager at Exactpro Systems Georgia. However, today I will have a slightly different role. I will be a moderator of this event. Before we move to the main part, I would like to ask my colleague Andrei to share a link with a question in the chat. So please follow this link and answer a pretty simple question. So how are you feeling today? And let's see the results together. Andrei, can you help me with the link, please? So I guess we have some technical problems with the link, so please write in the chat straightly how you're feeling today. Okay, so as far as I see, you're feeling pretty normal today. So let's move to the next part. As you may have already mentioned, our source of communication will be YouTube chat. So after each presentation, you will have up to 5 minutes to write your questions, and our speaker will answer them orally. However, after 5 minutes, they will move straightly to YouTube platform and answer your question in the chat. Before we move to the main part of our webinar, I would like to share some information about the company that we represent. Exactpro provides functional and non-functional testing services to exchanges, banks, and clearing houses, and also other representatives from financial industry. Company was founded in 2009 with only 10 people. Currently, we are up to 600 specialists. We were a part of London Stock Exchange Group, one of the biggest exchange in the world, from 2015 till 2018. And currently, we are an independent company with a headquarter in the UK and the operations in countries like US, Russia, and from 2018, we are in Georgia as well. Currently, we have 2 offices in Georgia. Besides providing software testing services, we have a team of developers who work hard to develop tools in order to test to test sophisticated and mission-critical softwares in the financial industry. So this is shortly about the company that we represent, and additional information you can find out on our website, exactpro.com. So let's move further, and today we are going to listen to 3 pretty interesting presentations from software development. Our first speaker will be Vakhtang Donadze, Java developer from Exactpro, who will introduce to you the notion of domain-specific language it uses and the reason why Kotlin is a great choice for creating a DSL. Our next speaker will be Merab Tato Kutalia, Android chapter lead from Tbilisi Bank. Merab will teach you how to achieve fast iteration and short feedback loops within product teams. And the last presentation will be by Anton Sitnikov. Anton is a chief software architect from Exactpro, and Anton will speak about reactive programming. So I guess we can invite our first speaker. Vakhtang, are you ready?
I'm here.
Yes, we can hear you well. Vakhtang?
Okay. tell me whenever I can start.
Yes.
Okay. Let me share my screen. So, hello everyone. As Lana mentioned, I work in Exactpro as a Java developer, and today my presentation is going to be about Kotlin DSL. And shortly, today we are going to cover what is DSL in general. Then we are going to see what DSL is good for and why should we use it. Then we will discuss why Kotlin is such a great choice for writing DSL. And at the end, we will have a small demo. So, what is DSL? To understand DSL better, let's compare it with the GPL. As you can see from the names, DSL stands for Domain-Specific Language, and GPL stands for General Purpose Programming Languages. We can see the first difference from the name is quite obvious, that DSL is for the specific domain, it's for the specific tasks, while GPL, on the other hand, is for a variety of domains, and we can write almost any kind of application using general purpose languages. DSL is also quite strict compared to the GPL in terms of what it allows us to do and what it supports. And I think if you look at the specific examples of each of them, you can better understand what is DSL and what is GPL. Like from DSL side, we have well-known HTML, CSS, XHTML. We also have XML here. And from the GPL, we know quite well-known programming languages like Python, Assembly, Java, Kotlin, Swift. Of course, neither of the side is the full list. We have many other representatives over each side, but I guess the main idea and the main image of what DSL and GPL are is quite obvious from here. So let's dive into more in DSL and describe two kinds of DSL. We have external one and the internal. External DSL is the kind of DSL which is created from the scratch, which means that we need to define grammar and the parcel for the whole language. We need to create everything from the zero. It will be quite time-consuming and hard to create. However, as it is totally up to us, we can customize and configure language as we want. So it's totally under our control, and it can be anything we want it to be. Comparing to this, internal DSL is built on existing language, which means that we have no need for another parser and a grammar. We are already using ones from the language that we are using for DSL. Thus, it's quite easy to create. However, because of its need to be based on a specific language, it's also bounded with the capabilities of this language. And finally, we need to know why to use DSL, and it has quite a few good points. First of all, it's because if it is strict and restrained, it gives us less room for the errors. So it's more probable that the code we write using DSL is correct and it will compile correctly. It's easier to understand for the people with no professional background in programming, because its syntax is cleaner, it's easier to read, and code is quite more intuitive compared to some other programming languages. It's easy to extend, especially in terms of internal DSL. We don't always have to create it from the zero. We can take some already existing DSL and just add our functionalities and transform it to our needs. And the last point, I would say the only drawback for the DSL is that we need to spend some time and effort to create it. However, after we have done this and we have already our DSL made, the future experience is quite positive and nicer. So let's see some examples of already implemented DSL in the Kotlin. First, we can discuss HTML DSL that is implemented in the Kotlin HTML library. If you ever had a relationship with HTML, you can easily understand that these are the few tags that HTML supports, and we can write them in Kotlin with this syntax, and it's quite obvious what we are doing here, and it's really easy to understand. Another quite useful DSL library from Kotlin is Anko, which is a DSL library for Android development, And here we can see how we create some text fields. We can also create button, assign it the size and functionality and stuff like that. So it's quite useful in Android development. Another very great example of Kotlin DSL is the Gradle build script, which makes building projects very easy. So why is Kotlin such a good choice for DSL? First of all, let's look at the main structure of the DSL. I think that from the previous examples and from this, you can easily guess what the structure looks like. We have some keyword, then we have braces. In braces, we can have another object, another keyword, and another braces, or we can have a direct assignment to the value. And how Kotlin supports this? Every DSL in Kotlin is type safe, the syntax is checked during compile time, and we have an IDE support for the DSL. It means that every DSL that we create in Kotlin is basically valid Kotlin syntax. The DSL that we are calling it is just a syntactic sugar, which makes it look nice. However, this is still a valid Kotlin code. Thus, we get every color highlights, indentation, marking, and all the great things that IDE can do for us in our DSL. In terms of specific characteristics of the language that supports DSL, is that in Kotlin, functions are an object, which means that we can assign them to the variable, we can define functions in line, and we can pass function to another function as a parameter. We also have name and default parameters, which if you are coming from C# background, you will know what they are doing. And it's quite obvious, like when we are passing parameter to our function, we can pass them out of order just using their names. And with default parameters, we can define the default value for the parameter during the function creation, and we don't have to pass this variable after when function is called. We also have infix functions in Kotlin, which are also quite a nice syntactic sugar. We will have example of infix function in our demo too, but to say shortly, infix function is any function that receives only one argument, and it is part of member of some class. If the function satisfies these two criteria, then we can transform it to an infix function. And as you can see, this function is part of the integer class. It is called on the integer object too, and it receives another integer object as a parameter, and then based on the name, it just returns the sum of it. The last two parts are extension functions and lambdas with receivers. Those are quite the basic of DSL and the most important part, so let's discuss them in more details. Lambdas with receivers are basically combination of extension functions and lambdas. And let's discuss them on the person class example. Here we have a regular class with only 3 fields. We have field name, age, and the profession. And first of all, let's create extension function for it. This is our extension function isTeenager, which returns whether the age of the person is less or equal to 19. The syntax of the extension function is the following. We define function with the fun keyword, and then we specify the class which the function is extending. Then we have the function name, parameters if they are needed, and finally the return type. The main thing is that inside this function, we have access to this keyword. And this keyword refers to the class the function is extending. In this case, this refers to the person. So we have access to the age field, so we can compare it to any number. The lambda expression is quite similar. We define the lambda variable, and the type is a lambda expression with a receiver. Here, our receiver is again the person class. And here we can see the syntax similar to the extension function. We have a dot, and then function that extends the class, and again the return value. And as you can see here, we also have the access to this age field. And how do we call these functions? We call them on the person object, as you can see here. We just create some person object, call it John, and we can call our extension function and lambda function on it. As you can see, the functions at the beginning were not part of the class itself. However, when we extended class with those functions, they act as they were a member function and if they had access to the fields from our class. So, how do we use our lambdas with receiver in our DSL? We mostly use them in the higher order functions, and higher order functions are the functions that receive another function as a parameter. In our case, let's create a function person, which will return as object of type person. This function receives lambda with the receiver. It's a person type lambda, so we know that inside this lambda code we will have access to the person reference, and in the end we just create a person object and apply our code to this person and return the result. So let's see, our function will look like this. We call the function and we pass our lambda to this function. A good quality of Kotlin is that when the lambda is the last argument, and in this case only argument, we don't need to write braces, these regular braces at all. We can just omit them and directly write our lambda. And as you can see, because of this receiver type, we can access name, age, and profession and assign the values. What's good about Kotlin is that the keyword this is inferred, so we don't really have to write it. It's automatically detected, and if you write just name, age, and profession, it will know who to refer. And finally, as our function is returning person, we can just assign this to any variable we want, and here it is our very first simple build with DSL. So now let's go to demo and see more of it. In demo, first of all, I want to show what we are going to be modeling. We will have such kind of thing. We will have a project simulator. We will create a class project, which receives the name for the project. It will receive list of tasks. It will receive threshold, which is how percentage of the tasks we need to complete to know that project is successful. And we will also have the variable that defines whether project was successful or not. We also have tasks with the name. We will have difficulty for the task, and for the simplicity, we will have just 2 employees who are working on the task. So we will have employees solving the tasks, and if they are successful, then project is successful. And finally, our employees will contain name, profession, the experience measurement, and also list of technical and soft skills, which are defined like data class here. We also have some implementation for this, like we have implemented our employee class, which calculates the total skill of every employee, and we're using these calculations in our skill class, in our task class, to define whether the employees were strong enough to complete the task. And of course, at the end, in project, we are counting how many of the tasks were completed successfully, comparing it to the threshold, and return the result. The implementation is not as important. We now focus on how to transform this kind of project creation. So you can see we create project as we would do it usual. Here we are using our named parameters. We are assigning name to the project like this. We are creating task as a list of the task, like syntax similar to this. We are passing employees to our task. So we want to transform this kind of project creation in something similar to this, which is our DSL. We say the keyword project, we open the Lambda expression, then we pass the name, we pass task as we want them, like this is one task, we start one task, then we pass another task, and each task contains the employees, which here are called manager, developer, and we create them like this. So let's start with creation and employee. So here we can look what our DSL is doing, and then we can also compare it to changes here and what they represent. To start with our employee, let's define an employee builder class to build our employee. Our employee builder class contains the same parameters as our employee class. As you can see, it has the name, profession, which are passed to constructor. It contains experience, technical skills, and soft skills. However, these variables are private. We don't access those variables while accessing here. We access the functions that we use to set those variables. In this function, we use our lambda with receiver. As you can see, we are passing a lambda, which is a receiver of type soft skill. Here we have our, soft skills list. So here we have our soft skills list class, which is extension of the array list. And this soft skill contains only one function, and this function is level. This function is extension function as well as infix function. So first of all, let's take a look at this level function. Here we can see the syntax that we are using it in our main class. So how does it work? As you can see, we are extending string class, which means that function will be called on the string object. And here we can see that we are calling it on the string. It receives parameter of the type int. Here we give the int parameter, and at the end these parameters are added to the list, and the list is returned here as a return value. In Kotlin, if the function is just only one line and this line is the return line, we can write it like this, equal sign and the return value. So we discussed this class, and we know that our soft skill will receive lambda, which is supported with those things. So our lambda will have access to the level function. So here we can see the soft skill. Inside soft skill, we have access to the level function. We are creating our skills, for example, leadership skill with level 6 and the problem solving skill with level 9. And then those skills are added to our private variable. At the end, we have the similar case for the technical skills, of course. And finally, as class is builder, we are providing a build function which returns the employee class build based on the variables that we created and assigned in our employee builder. So how do we use this employee builder in our tasks? As you can see, task is created with the employee. However, we are calling them just as manager and developer. So how this is done? In our task builder, you can see the regular thing like a name, difficulty, as in the sketch below before we seen it. And also we have a private variable, similarly, employee 1 and employee 2. And as you can see, we are not accessing those private variables from our lambda. We are accessing those two functions. Those two functions receive the same employee builder block. The only difference is that inside the function, I decide what kind of employee to build. I build the employee with the name provided in the function, and also if the function is manager, I pass the manager profession to the employee builder directly. So here, when we are declaring manager, we don't have to write this variable. It's already managed and taken care of inside the function. So this also gives us the possibility to shorten our syntax and make it more visible. And for the same thing, for developer, it's still same function. However, instead of manager, we are passing a developer keyword. Similarly, we are building our project with our project builder. It has the variable name and threshold, which are accessed directly. As you can see here, we are accessing name directly, and at the end, we are accessing threshold directly. However, to create an array of the tasks, we are using, again, the function for it. We are using function task, which will receive our task builder. We know that in our task builder, we have access to the difficulty for the task. So in task builder, we pass the difficulty. And in our task builder, we have access to the manager and developer things. So this is our building. And in the end, we are making our global function project, which starts our DSL. As you can see, the project is our main function, it starts DSL. It starts with it receives again the project builder lambda. And in the end, we are applying the block of code to our project builder. We create instance of the project builder, and we are calling the build method on it, which builds our project already and returns the project. So as you can see here, the return type of the project function is project. And as you can see, this is our DSL in the end, which for me at least looks much nicer and cleaner than the previous way of creating this. So we should also mention that Kotlin allows us to create global function like this. As you can see, this project function is not a member of any class. It's just defined directly in the file. Kotlin also allows us to create several classes, several public classes in one file. So we don't need to stick to the Java convention one file for one class. And also we don't need to have function inside the class. We can just create them on the blank file, which is quite useful. And as you can see, we found use for it in our DSL too. I guess this is everything from the demo. You can see code for it, and in GitHub repository, link for it will be shared in the video description or in chat. You can find the code here, and if you want, you can look through it and see the implementation and all the details. And follow us on social network. You can easily find us. And thank you for listening. I think that's all from me. If you have any question, I'm ready for it.
Thank you, Vakhtang. Sorry. Thank you, Vakhtang, for the interesting presentation. So, guys, if you have questions, please write them in YouTube chat. But before you write the questions, we have one link that Andrei shared with you. We would like to share the results. Andrei, can you please show the results for the previous question that I asked at the beginning of the webinar? So before we share the results, write the question in the YouTube chat. So as far as we see from the results, most of you is feeling good, which is really very great news. But also I see that some of you is waiting for the weekends and also for 2020 to end. So good news, it will end really very soon. And I hope that 2021 will be more productive and less stressful for all of us. Now we can move to YouTube chat and ask Vakhtang the questions. So Vakhtang, we have one question from Luka Vadachkoria. Can you describe your experience of learning Kotlin coming from a Java OOP background?
I mean, I guess if you have the question, you already know that Kotlin is basically based on Java. It uses the same Java JVM. It compiles code to Java. So at the end, the Kotlin code is compiled to Java, and it supports everything that we had in Java before. However, it provides us quite nice syntax sugars, and it gives us possibility to do more fun stuff for me. I mean, like for now, Kotlin is one of my favorite languages in terms of things it can do and how compact and well written the syntax is. And It's really good to have a Java background because you know all the main basics of object-oriented programming, and then you are just switching to a language which gives you a bit more possibilities in terms of making your code shorter with a nicer syntax and some nice things attached to it.
Thank you, Vaho. So, Vaho, I guess you can move to YouTube platform and continue answering the questions straightly in the chat.
Okay, thank you.
Thank you once again. Now I would like to present our second speaker, Merab Tato Kutalia. Merab, are you ready?
Yeah, hi.
We can hear you well, so you can start.
Yep. So, yeah. Hi again. So today's topic is mobile DevOps, and yeah, why the reason I'm presenting this session is that the DevOps culture sometimes is underestimated by developers, mostly developers, and during this session I want to talk from the developer's point of view, how crucial this skill is for, and basically that's the main point today's presentation. I'm Tato Kutalia. I'm the Android chapter lead at the Tbilisi Bank, and you can find me on this website. And I'm a host of the Debugger podcast. It's in Georgian language, and some interesting topics are there. Okay, let's start. The plan for today's session is live before the DevOps, how it was before, and then why DevOps matter for the business, for the team. The crucial part is the team always, and what is the role of this CI/CD in agile teams, and then later going mobile. So what is to do DevOps in a mobile team, and why it is a bit different approach, and what are the available solutions on the market for the mobile specific tasks. So first of all, before I start, maybe 10 years ago, developers were not required to know a lot of servers and stuff like this around it, but now everything is much easier. So that's why I'm talking that I will talk during the whole session from developer's point of view why it's important. And now it's much easier, and we want to be a part of the team, product team, which crafts the product. So we need to know the ABC of the DevOps at least. So bear with me with this session until the end. So how life was before the DevOps. So first, business was the driver. So business set all the requirements. Business wanted everything yesterday, and all the tech stuff was there to support the business, not to build a product together. Yeah, the idea was to build a product at the end, but the way to approach it was completely different. Yeah, and on the tech stack, the technology, I mean the code, everything, it was a huge monolith. So monthly releases at most, it was available with these systems. Yeah, and each feature release had been development and testing for multiple months, because the huge monolith needs to be tested, then some features will be added, and you got another problem, then you need to do regression tests, and then you have to apply hotfix, and it was totally mess. And that's why QAs also were struggling. We had low test coverage and distribution, because it's very hard to move with all the dependencies on the hardware and on the software, and your distributions are also slow, because instead of distributing test builds, for example, or some staging versions in every week or twice in a week, you go for okay, let's do this once in a 2 week, and then a QA will return with a long sheet of bugs, and okay, we can do a hotfix, and then apply it to the production. So that was the problem of chains before that. So, and rollbacks were hard. So this is on how it was on a top level. Now let's talk about on tech-wise, and okay, let's dive into the details a little bit more. So sysadmins, you all know this word, yes, sysadmins. The sysadmins were a kind of bottleneck. So I'm not going to talk any bad stuff about them. It's just a profession, but in many cases they were bottleneck because, let me clarify this. Sometimes business required some kind of feature, and developers were like, okay, we need 2 weeks and we'll hack everything, we will do some workarounds, and everything will be fine. And for example, developers did their job, but sysadmins had some kind of different architecture on the server. Yeah, maybe it was done on the engines and everything was the Apache, and the sysadmins were like, okay, now we need another week to set up everything, to do a proper security stuff, to push it on the productions, and I don't know, write some shell scripts for it to automate everything. And yeah, the problem was that tech hardware and software were not separated. And the main idea why the software is called software is that it's not dependent on the hardware, and you are agile. You are allowed easily to change your product behavior. And in this monolith, it is hard for you to change. Yeah, I know there were virtual machines and everything, but still you need to set up these virtual machines. You need to support and maintain it, and even under the virtualization, you need some kind of hardware to support this whole ecosystem. Yeah, so that's a problem. And containers, no, there were no containers before, at 10, 15 years ago, at least in Georgia. Yeah. So mindset about that some services might be in containers, it was out of the scope. So, and this was out of scope even for sysadmins, and for the developers, it was, it was some kind of mystery. It's some black box. So they didn't understand this. So, and during this, all the problems, on the developer side, we had another developer problems. Yeah, we are also people. Yeah, long living branches. So it means that 3 weeks of 1 month of development, it's on a separate branch. And now, guess what? You have to merge this whole chain of commits into some main develop or release branch. I don't know, in any branch, and someone had to review this work. So 1 month of work, and someone had to review it, and then you had to take this responsibility to merge. It's nonsense. And then if something happened, rollbacks are hard, and also QAs are struggling because they have to test the whole feature which developed during this 1 month. So everything was slow, and everyone was taking big steps. So everyone was trying to do big steps, but in reality, everything was slow. And I believe that some of you still remember this time that the pushing from the development local machine directly to the production server, it was okay, and it was done via FTP. I believe that some of you still remember this time. So it was awful. And I forget that during this migration from local to production, also there was some problem. It's not a problem actually, but staging servers were not as frequent as now. So only big companies had resources to support, maintain, to have this staging extra layers of servers, for example, from the local machines and to the development server, and until the production, there was some kind of staging server which was configured like a production, but it was a separate layer. So before the modern DevOps, it was extra work for sysadmins to synchronize everything, maybe run some async commands to automate everything and stuff like this. So it was a additional huge layer for it. Okay, so and let me give some representation because all the history until that it just works. Okay, let me represent it with this chart, and it will be much easier to get the idea. So now we have the release 1. So everything is fine. We start our first release, and yeah, we have development phase. It's the standard waterfall method. Yeah, you start development, and okay, it's a business planning before and stuff like this. But you start development, then you start testing, and then you have release. Okay, sounds good. Okay, it works. Not perfect, but it works. Okay, then later, second feature we need to start. Yeah. So development phase is already done, and what developers are doing? Starting second feature. Yeah. So they don't have free time. We have to work always because we want to build products. Okay, we started another development feature. Okay, and this testing will be delayed a little bit because testers have free time, spare time after they finished the test here. So they started to test another feature, and etc. So release 3. So here is development and testing, and everything is delayed. So waterfall and standard waterfall. The problem, the bottleneck lies here. So after this third release, you have release, testing, and development, this whole chain on the same track, in the same team. So if something happens on any of this part, your whole timeline is screwed. So if release fails or some major bug appears, you have to stop developing, you have to stop testing, and you have to fix release branch. Yeah. Then if there's some problem in the testing, what developers should do? Fix the second release or continue working on the third release as usual and fix bugs in there some this spare time. Yeah, after the development phase. What is the strategy? Yeah, basically this is the bottleneck, and this was the problem. So I know it's a big picture. It's not only related to the DevOps, but I'm trying to crawl step by step to the agile mindset and the DevOps as a mindset. Not the DevOps as a Docker on Kubernetes or something else. No, DevOps as a mindset and the part which plays big part in the agile methodology. Yeah. So yeah, and what if you found a bug in another releases? Yeah, so you're screwed. So what is a DevOps? This is a very famous representation what the DevOps stands for. Yeah, it's a standard release, deploy, operate, monitor, plan. So it's a bunch of words, but the main idea is that DevOps, according to Wikipedia, DevOps is a set of practices that combines software development and IT operations. So okay. So it's a development plus operations. Okay. So development part is we code. Yeah, it's in our DNA. We code, we build, test and break things. Okay. And then we release, but release is part of the operation as well. So okay, release, deploy, operate, monitoring. And yeah, then we get feedback. We broke some stuff again. It's also in our DNA. We break things always. So then we plan again how we have to fix the things we broke, and plus add new bugs to the future. It's very natural. So okay, again we plan, code, test. It's the cycle, and the sign itself is the sign of continuity. Yeah. That's a mindset, yeah. It's not only the techniques, it's a mindset, and because of this mindset, the techniques, libraries, frameworks, all the tools were built on the mindset and the requirements, yeah. And we, as a part of the product team, are required to know the mindset as well the tools which solve the problem. So that's DevOps, yeah. I, as a software engineer, and the most importantly, I'm a guy who builds the products, it's important to have short feedback loops and frequent releases, yeah? And it should be fast and easy to maintain. So let me repeat again. And it should be fast and easy to maintain. The key is that it should be easy to maintain, because we had all the tools before, yeah? We had servers, okay. We had Nginx, okay. We had the same application build pipeline, but it was not easy to maintain. It was not cheap. It was not fast, yeah? And fast to change, yeah? It was completely different monster, yeah? And the mindset is that it should be easy. And why it should be easy? When you get new team members in a team, it should be easy to onboard the new team members. Teams not always focus on building extraordinary systems and stuff like this. No, it should be pragmatic sometimes and maintainable, so easy to work. So let me tell you now what the DevOps mindset looks like. Yeah, it's an agile way of doing things. Okay, now I hear another methodology or some kind of word, agile. What's agile? Yeah, what's agile? Okay, agile is completely different mindset. I will not going to talk about a lot. Just bear in mind that this agile works between the business and developers mostly, and developers are the part of the product team, so they are not in a separate room and doing some nerdy stuff. No, we are a part of the product team. We had to communicate. We are not nerds as it was 50 years ago. No, we had to communicate with the business people. We had to communicate all the way with you, UX designers, UI designers, QA, stakeholders, everyone, because we want to build products. But DevOps, on the other hand, is to make easier communications with the operation people, so like sysadmins and network administration and everyone, yeah? So it covers the gap between the developers and the operation parts with the developers. So now we have this kind of graph which shows what is the DevOps as a mindset for us, yeah? So we start development, okay, we test it, we release it, and we support it, yeah? It looks like waterfall in one release, but the key is that it's very, very short in a timeline. So we do very little steps. We are faster because of it, and it's easy to roll back for us. It's easy to reinvent something. It's easy to fix some bugs. It's easy us to do some regular releases because we are agile. We do small steps, we do small features, but we do it frequently. So that's the agile way of doing things with DevOps. So then DevOps covers the gap between this whole development operations. Okay. Releasing, deploying, operating, planning, coding, building, testing, everything. And that's why developers, as I said in the beginning, that's why developers are required to know a bit of the DevOps. There should not be a full qualified DevOps engineers. I'm not full qualified DevOps engineer, but I can build systems which can support my product and yeah, almost everything that I need. But this should be very common for all developers because they should be on board and they should solve the product problems, not only their problem, the product problems that they need. So let's have a glance of these features, cool features of DevOps. First is rapid delivery. Yeah, you should release faster and you should do it rapidly. So bi-weekly releases is good, perfect. Yeah, in every 2 weeks, you plan, you build, you test, you release. It's constant, it's always. So you are in these loops that you're doing these small iterations, but you have small problems because of it. Yeah, imagine imagine with these delivery types also, yeah? Sometimes you have different flavors like Google, Huawei, and for some test version, testing version, release version, debug version, it's some kind of different applications you need to on your local machine, on the testing server, and on different locations, yeah? Because of this DevOps infrastructure, which we'll be talking later, it's a lot easier because now you have the automation. You are not going to build this on your local machine. You build it on the separate deploy or testing or building server. So we will talk this later. So feedback loops, yeah. Another mindset. So okay, today this session is all about the mindset, because if you have a proper mindset, you can approach any tool and be in any team and do a really cool product. Yeah. So the fail fast is a methodology. It's a mindset that okay, we failed, we broke the thing. Okay, now what? Now we analyze it, monitor, and apply bug fix and release it faster. Yeah. Because another thing that will break, we have to fix it again faster. So we are always running. That's a mindset. And now the plus side of this is that we have short living branches. Yeah, everyone has to review 4 or 5 days of work maximum and reduce branches, because you have small features to do. In 2 weeks, you have very small amount of a very few amount of features, yeah, and we have more pull requests, yeah, and less pull requests because there are few new features. Also, the additional benefit is the pull requests are easy to review, as I said, and because it's easy to review, you feel happy and positive, and your team members are also okay, because imagine that you have to review 1 month old pull request with, I don't know, maybe 20 commits and changed 40 files. And on a Monday morning, you sit with your desk and, okay, scrolling this whole changes. The whole day, it's nightmare, yeah? It's nightmare. And compare it to very small changes, the actual product changes, the business, user stories, specific user stories you have to do. Yeah, it's much easier, and everyone is happy, and you are happy to give some kind of comment or to leave a review on the source control system, because it's easy to change. Everything is a bit easier. Plus, QA is happy because they can get new test versions much faster. They can return the feedback, the found bugs, a much smaller amount, and then it will be fixed faster. So that's a cool way of doing things. And this, security part. And security part is that I'm not deep diving the exact DevOps technologies, build tools, because this will be I don't know, 6 hours long session. But we know the Dockers and stuff like this. So security is that we have very restricted sandbox. It's a small box, and each service is separated in their own boxes. So this gives us ability to deploy it faster, destroy, repair, and deploy it again. So instead of setting up the whole virtual machine, now we have containers, and it's much low cost, and also it's easy to learn. Yeah, that's a bonus. Managing credentials is also easy because also we have a lot of cloud providers now for doing the cloud DevOps, and such as AWS, Azure, Google Cloud, and for the mobile there are plus a lot more to do. And they store the credentials, and you can also have your own DevOps infrastructure inside your company, and you can store it on encrypted storage, and basically it's much easier to store some kind of credentials. It's not it's not the completely opposite of how it was before, but yeah, it's better and agile. And continuous monitoring. So we have tons of monitoring tools to monitor our system status on each layer. Yeah, it will be on testing, releasing, and whole chain of tools we have. So, and let's talk about a continuous testing. Yeah. So okay, builds for QA should be separate than the developer builds. Yeah. And developers don't want, and it's not correct to always build on a local machine for the testers, QAs. So we need some kind of server to provide them a build. And then we need some unit. So the continuous testing is a core part of doing the DevOps. If you don't have a continuous testing, you're not doing the proper DevOps. It's continuous, might be a continuous integration thing, some kind of thing, but the continuous testing is the key part. So the testing on the Android side, mostly, it's on very different levels. You have a unit test, you have the integration test, etc. But you have also UI tests, which will be on Espresso, and plus you can have another layer of the testing, which is automated tests by QA, which is not from the developer, but from the actual QA. So you can run these scripts also on, I don't know, it's on Appium, but the base is Selenium, yeah, JVM. So you can run this script on the building server as well. So, and then automatic delivery, it will be via Slack, Telegram, Firebase, Beta, I don't know, via Parcel, I don't know. But this thing is that this whole system should be pluggable. So yeah, plug and play, yeah. So it should be easy to consume this build after it's done. So, mobile DevOps. So what are the key differences in mobile DevOps, unlike the other systems? First thing is that, yeah, it's mobile. We need to know the mobile release flow. Yeah, how mobile applications are built, and what are the key parts during this build, and how we can support these tools to have it in the pipeline. Yeah, so all the mobile tools, and they are a lot, and they need to update frequently, but this will be done in the cloud, and it's easier to maintain. Yeah, and then we always need to keep artifacts. The artifacts are like test APKs, test results, the mapping files, and then typical output. All are considered as the artifact, and we need to keep them. So every artifact should be stored, because sometimes we need to compare our current version with a 6-month-old version, because we need to monitor the changes, how this code size, the compressed code, I know, but we still need to check how it's growing, and what is the percentage of the resources and the actual code in there, and if there are some problems. So in short, we need to keep artifacts, and also manage multimodal builds and tests. You know that Android, iOS systems support different variants of builds. As I mentioned before, it will be Google, it will be Huawei, maybe tomorrow it will be some kind of Xiaomi thing, and we need to have some testing environment, staging environment, which will be connecting to the different endpoints, some different credentials, and this, our pipeline should support all these multimodal builds, and sometimes we need it to have all together. So we need to support concurrent builds as well, yeah, and to test them in a different modules, because each module now has separate tests, separate integration tests, separate UI tests. So it's more complex, you know, this whole mobile architecture, and that's the mobile DevOps. So what are the options to support the mobile DevOps? So As I said, I'm a mobile engineer, and I always, during this whole session, I was talking from the developer point of view. So from the developer point of view and from the team's point of view, sometimes and most times it's easier to get cloud vendor, which is already well established and well secured, and use it. It's Bitrise, Circle CI, Bitbucket pipelines, Travis CI, and stuff like this. And you can do some few mouse clicks. Not that easy, but it's much easier to set up a Jenkins server on your local environment. Yeah, you know. So from my very nerdy engineering point of view, I like setting up Jenkins and putting on the bash scripts, preparing Docker image on a Docker hub. And it's cool. It's cool to build things. But when you're in a product team and when you need to ship releases faster and maintain easier and to get new members on board, maybe you need to choose some different options. So those are the Bitrise, Circle CI, and stuff. Many of them which are all ready for Android and iOS as well. So basically, that's it. If you have any questions, so I'm here, and I'm very glad to answer you. So main thing is that to change your mindset, be agile, and always think how it will be easier to build the product instead of just hacking all things together. Thank you.
Merab, thank you for the presentation. It was really very useful. So if you have any questions, please write them in a chat, and Merab will answer them. So let's wait for 1-2 minutes, and then Merab, you can move to YouTube platform straightly. Okay, Merab, I guess you can move to the YouTube straightly, and we can move to the next speaker, to the last one, Anton Sitnikov. Anton, are you ready?
Hello, Lana. Yes, I think I'm ready. I need to start to share my presentation. First, let me. I think it should be visible. So I want to talk about reactive programming and what new may come in this area. Actually, the problem which Project Loom tries to solve, it's very old. I will show it a bit later. And I think many of you have at least somehow touch these problems. Let's take a look at this very simple web application. It's some example which from Spring Boot. So here we get REST application which has employees endpoint, and it returns the list of all employees querying some repository. It's maybe a SQL repository, and Hibernate or similar library can be used to access the data. I think many of you have written code like this because Spring Boot is a very popular framework, and I think a very big amount of Java applications we have currently live. It does very similar things. Let's convert it a little bit to highlight what is really interesting for us from this example. So actually what this code performs. It reads some data from HTTP input stream. Then some transformation to the data happens. Then SQL connection, the JDBC driver, it has a connection to some SQL server. It writes SQL command, select asterisk from employees. It writes it to some other output stream, other socket, and then we try to read reply from SQL Server. It's the next line where we get results set. Then we do some transformation, and the last piece of work in this example is to write it back to HTTP output stream, where browser will be able to get the response and show it to the end user. So when we look all these operations, we'll realize that all these operations are blocking. So when we do read from HTTP input stream, we may block for some time before the data is read from TCP from the network. And at this time, the computer, the thread on which this code is executed, it will do nothing. And the same with write. We may have some issues with the network, and this write can take longer than expected. So again, we may block on writes, and then we get another point when the read happens, when we can block, and the same with write. If we have application which handles multiple connections, then we will have multiple threads which spend most of its time in waiting for some external data, external events. At first sight, it doesn't look very bad, but in Java, every thread is linked to hardware thread, and actually each hardware thread requires about 1 megabytes of RAM. So we, even if it's a very simple application which does not much processing of the data and doesn't need so much RAM for execution of real code, we will still be paying 1 megabyte per each thread. It's not very dangerous for applications which don't need to handle a big number of connections, but it's obvious that if we have thousands of connections which should be processed at the same time, we will consume lots of RAM. So this megabytes will become gigabytes, and this we will spend just enormous amount of RAM just for nothing, just for waiting for some external data or availability, some resources, and so on. Of course, in the example I shown before, with Spring Boot, it's not that bad, because Spring Boot takes care on the HTTP part of this application, and not so much threads are used there. But if you look at JDBC drivers, most of them are very simplistic, and they don't utilize anything like thread pools in some cases, not even not because the developers of JDBC drivers just don't want to use it, but just because they simply can't. Because JDBC, if we recall the old Java Enterprise applications in this world where JDBC drivers, the same JDBC drivers are used, all thread pools should be controlled by application servers. So a JDBC driver cannot spawn new threads or operate new thread pools because it will violate the requirements which application container applies to applications which run in it. Of course, there are other approaches because as this problem is really old and I think the more modern approach to solve this problem is asynchronous approach, where instead of waiting for data in blocks and blocked operations, we write a code which just reacts, which is executed only when data is actually ready. But Java language isn't very ready to such approach, and as a result we get the code which is not easy to write, not easy to read, and not easy to support. Here you can see the example how SQL query using Eric Java can look like. So it's lots of lines of code and just to get to execute SQL query and convert a result to the list. And here we even don't execute other operations in parallel. So if we add more steps to this, try to do some operation for every article, probably querying some other information for it, the code will become even more complex. So to summarize what we have, we have a world of synchronous applications, which is simple, which are easy to read, easy to maintain, but these applications are less scalable. And we have a world of asynchronous programs which scale very well, but which are complex and they're hard. It's usually hard to debug such applications because from what is for debugger, it's hard to predict where your next execution point is because it's not linear Java code. It's just invocation of different methods, and they are invoked from deep of frameworks, from deeps of frameworks like Java and so on. So, and the project Loom tries to tries to solve this problem from different angle. So Project Loom offers 3 cornerstones from which it is done. The first one is fibers. Fiber is lightweight thread which isn't bound to hardware thread. In Project Loom, they don't use term fiber. They name them virtual threads. It's because they decided not to create new entity for fibers. They just reuse the old thread interface, thread class interface, which is well known, and they have just extended this interface with a couple of new methods. Continuations, it's the thing which you probably will never see when you use Project Loom. It's the way which the internal entity which allows multiple fibers to be executed on the same thread. So with hardware threads, if you spawn, for example, several thousands of threads, this thread will actually execute in parallel because it's done in hardware. With fibers or virtual threads, only one fiber can execute at the same time on hardware on real thread. And if we have more fibers than physical threads, then we need some way to switching between one virtual thread to another thread. In continuation allows to mark explicitly mark points in code when we want to stop execution and give control back to scheduler. In case of network example we had before, for example, when we try to read from the socket and there is no data in it, it's a good point where such a good point when fiber execution should be paused and control returned to the scheduler. And continuations, they provide means for doing it because when the execution needs to be resumed, we need to start it from exactly same point, and Java does it by storing information from call stack, object from call stack, and allowing to return to the same point where it was paused. And scheduler is an entity which allows switching between these fibers efficiently. Again, in Project Loom doesn't invent anything very special for this. They used fork chain pool, which exists in Java for many years, but they added additional mode, which they called asynchronous mode to fork join pool, which behaves slightly different in terms which task is picked from the queue first, comparing what it was before. So let's assume we have Project Loom in our project, and the question is what is needed to convert our network program to get all benefits from Project Loom. Let's look at the code. It's actually absolutely the same code. So Project Loom, the magic of Project Loom, but it does everything for you. So if you execute this code on virtual thread, the read operation will not block. It will actually yield there is the execution control to other possible fiber which waits in a stack to be executed. It's done because besides it's possible because besides of adding these three things, fibers, continuation, scheduler, Project Loom aims to they actually write and they actually wrote implementation of sockets operations to take all benefits of this lightweight threads, and it means that all what if you have some Spring Boot application, basically you don't need to do anything to make it more agile, more and consume less resources. No, of course, you will need to switch to new version of Java, which supports Project Loom, and probably to a newer version of Spring, which is different, creates different thread pool, which is fiber aware and all, and you will have linear applications. It sounds like really cool. Let's look at some other example how we can create some parallel tasks if we need to query several things in parallel from our application. So all you need to do is create another thread executor. It's a new, it's virtual thread executor created, and then you just add tasks to this executor and all. So when try the resources block is over, at this point, the application will wait for all this child execution to finish, and this code actually looks like sequential code. So even if when you spawn a new execution processes, you still have it as linear code. There's no need in complex code like you saw in Java, when you have to write lots of lambdas to achieve similar thing. Okay. For me, it looks like probably everything developer may want, but when I see something like this, for me it looks too good. So usually there are some cons, something which what is hidden, and what the project developers don't really want to show the public when they present new technology. Let's look at these things. So let's imagine we need not to query SQL database to get data. We need to return to our web client, but we need to read it from the file. The code looks absolutely the same. We still use input stream and we read the data from it. But the problem here with Project Loom developers, they have retrofitted only socket operations. So all file operations remain blocking ones. And here we, I think actually, I don't think it's the worst part. The worst part is that we use the same read from the stream in both examples. And if in one case, when we work with socket stream, it will perform perfectly on Project Loom. We will we will not block, and another fiber will get a chance to be executed at this point. But if we pass different stream to the same code, it may start behave absolutely differently. It may actually block the fiber, and it means that the real hardware thread is blocked, and in worst case, if we have many such waiting threads, we will get the same picture as without new fibers, without Project Loom, that we will have lots of hardware threads and big memory consumption. And you cannot tell if how it behaves looking at the code when read is called. You need to know which exactly input stream it is to realize what actually will be done here. Another thing which isn't perfect is that thread interface is reused. Now we have two threads which have absolutely different characteristics. And while one thread can effectively handle input-output, but at the same time, these fibers, there aren't real threads. So if, for example, if you need to do some computation work, you have to do it in real threads, because fibers cannot be executed really in parallel. So they can just yield the control to other fiber, but they can't. So if you have 1,000 fibers, only the amount of real physical threads, the fiber will be executed at the same time. But again, you need to know on which thread, how this thread was actually created to understand if it's a real thread or if it's a virtual thread. Let's look at another example, because besides the web applications, when we basically can't control how many customers, how many clients are connected to the application. So in this case, we either are able to handle this load or not. There are different kind of applications when we need to process data as fast as possible. For example, we have just a single connection from which we read requests, and we can process these requests independently. And as a result, we need to, after we do some processing, some enrichment of this data, we need to store it somewhere. So it's usually it's done like it's a producer, consumer, and data pipeline between them. So in theory, it fits very well in Project Loom ideology, because it's a linear program. We have we read something, then we spawn another fiber which does some work, and then writes the results to consumer. So it looks like very simple linear code. But what will happen there if consumer is much lower than producer? In this case, we end up with more or less the same as in old Vault application. We will spawn more and more threads. Of course, it won't be such bad as with hardware threads, because fibers need much less memory to work, but still we will have the same picture. We will will spawn more and more fibers, consuming more and more memory, and at the end we will get crashed because out of memory. So in to deal with that, back pressure is needed. So we need a way to talk to producer, but it needs to slow down a bit if we see that consumer is slower than producer. So in Eric Java, it has such a mechanism. It's not really visible, but actually the same idea. So in Eric Java, you have clear separation between producer and consumer, and Eric Java adds back pressure, so behind the scenes. So if you need to write such kind of applications which need to take all possible hardware resources and get all that possible from the hardware, Project Loom probably won't give you much, and we need to wait. I think it's possible to do back pressure in Project Loom, but it wasn't intention of Project Loom development. So we need to wait for new libraries built on Project Loom, which will add this back pressure functionality out of the box. Now, I think it's an interesting question: who wins in this situation from Project Loom, from presence of Project Loom? If we again see a regular application, web application, which are I think millions on the market. Most of them are similar to what I shown in the first picture, and usually they don't handle big load, and even if so if it's executed on some bare hardware and a real machine, not virtualized, the resources of this machine is enough for handling the load, and the real benefit will come when we want to execute several applications on the same box. In this case, really, we will be able to save a lot of memory, and we'll be able to squeeze more application into one box. And again, these applications, because we don't the file input output weren't retrofitted, so this application should be informed that we get something from the network and then send something to the network back. I think this approach it should look familiar when multiple applications are put into single hardware. Of course, it's cloud application, and so the real winners from Project Loom are the cloud providers, because they will be able to save a lot of resources, and when it comes to saving of this scale, it can be real saving, real money. And for developers, as I say, because when no matter if it's executed on real hardware or in cloud, currently the developers are more or less happy with current technologies, And Project Loom adds some benefits in forking the jobs and cleaner code, but I think that to do really challenging tasks with Project Loom, we need to wait for a new generation of frameworks or still use the reactive approach. I've done. I think you've already seen when where you can find us on the social networks in Vakh's presentations. So, do you have any questions?
Anton, thank you for the interesting presentation. Can you please move to the YouTube platform and answer the question directly to the chat? The chat will be active for 5 minutes after we finish the webinar, so be active there and Anton will answer all the questions. I guess it's time to close the evening. We hope that the information that you received on the webinar was interesting and helpful for you. I would like to thank all the presenters for the productive evening as well. And we will have much more webinars in the future, so keep an eye on our website and Facebook group. And also, as we are constantly trying to improve ourselves, we will send you a feedback form tomorrow. So please share your impressions and recommendations with us so we can consider them in the future. For now, it is all. As I mentioned before, the chat will be active for 5 minutes after we finish the webinar, so you can ask the questions there. Thank you once again and have a great rest of your day. Goodbye.